All right, so we're going to talk about here in part 5, measurements, reporting measurements in science and chemistry specifically. Um, One of the things you have to get used to in science, not just chemistry, is that numbers have more meaning than they do in just a pure math class. The numbers are always going to be coming from some sort of measurement in a lab room. So you have to treat numbers in science kind of a different way than you might treat them in math. So when you're recording a measurement, the first rule is that you should report any measurement to every digit you're certain of plus one uncertain digit. And we have a special name for these, as you can see down here, and this is called significant figures. So when you take a measurement, that measurement's going to have a certain number of digits in it. And however many digits it has, that typically represents the significant figures. But you can sometimes have measurements that require what we call placeholders, but are only there because they have to be. They're not necessarily part of the measurement. It gets a little confusing. We'll discuss it later on. The digit that's farthest to the left is the most precise or most accurate, and the rightmost digit is the least accurate. And that makes sense because as you're going farther to the right, you're going past the decimal, and there's less certainty with your measurements as you go farther to the right. So any measurement you take, whether it's with a graduated cylinder or a ruler or a triple beam balance, whatever the case, any measurement you take in class should be always recorded with all the digits you're sure of plus a guess, and that's going to change. So you can have a graduated cylinder that's accurate to the 1 milliliter, or you can have a graduated cylinder that's maybe accurate to the 10th. So those two measurements are going to look different, even though you might have the same amount of water in both graduated cylinders. So for example, down here at the bottom, if a graduated cylinder is accurate to the 10th of a milliliter, well, that means I'm going to record it to the 10th plus a guess. And of course, the guess would be to the hundredths. Okay? However, if the graduated cylinder is accurate, say, to the ones, then I'm going to record that to the ones, and then I'm going to guess the 10th. It just depends on the accuracy or precision of the instrument you're using. So we have a few examples here. First couple are with length. So let's take a look. We have a ruler here that has centimeters, and you're supposed to record how many centimeters long this pencil is. Well, each one of these lines represents a centimeter. Do you see any lines in between? No, there's nothing there. So we can only be accurate to the centimeter here. In other words, I am sure it's past 9 and before 10. So by writing 9 in my measurement, I'm certain of that. And then in between the 9 and the 10, I don't have any lines to go by. There are no increments here. So I'm going to have to guess the number that's in the tenths position. Well, it would be a good guess. It's going to have an educated guess. Maybe 9 point, and I'd say this is just about halfway, maybe not quite halfway, maybe a 4. We went with 5, 9.5 centimeters. Well, that doesn't mean that you couldn't write 9.4 or 9.6, but I think it'd be kind of a stretch to write something like 9.1 or 9.9. So your guess, even though we're calling it a guess, still needs to make sense. So if I was recording the length of this ruler, we kind of gave away the second one there. If I was recording the length of this ruler, this pencil, and I wrote, say, got a little technical difficulties here, sorry, and I wrote something like 9 centimeters. Well, now I'm telling anybody that's looking at my measurement that I didn't have any certain digits, that I was guessing the 9. And that's just not true. I'm certain of the 9 using this ruler. Well, what if I wrote 9.51 centimeters? How's that? Well, I'm guessing the 5 and I'm guessing the 1, so you can't guess twice. This is too precise. This is not precise enough. So it would be incorrect to record the measurements this way for this ruler. Well, let's jump down to the other ruler. This ruler, we see 1, 2, 3 centimeters, but we also have increments in the middle here. Those are actually millimeters. So in this length measurement, I'm sure of the 9, and then I look and I see 1, 2, 3, 4, 5. It looks like it's right on the 5. So I'm sure of the 5. And are there tiny little lines in between these lines, these millimeter lines? No, there's not. So I'm sure of the 9, I'm sure of the 5, and I'm going to have to guess my hundredths. Well, what would be a good guess? Well, it looks like it's right on the 5. So I'm going to guess a 0. Could I write something like 9.51? Yeah, that would be okay. But you're kind of stretching it if you're going to get past the 2 or 3 or the 4. But what if I wrote 9.5? Now what am I saying? Well, I'm saying that the 9 is my certain number and I guessed the 5. But in this measurement, did I guess the 5? No, I didn't. So that's an improper way to record this specific measurement. Well, what if I wrote 9.501 centimeters? Now what have I done? Well, I'm saying I'm certain of the 9, I'm certain of the 5, I'm certain of the 0, and I guessed the 1. Am I certain of this 0? No, because there's nothing in between these lines to tell me if it's right on 0, if it's a 1, 2, or 3, or 4, or so on. So you have to be careful when you're recording like this. All right, now we jump down to the graduated cylinder. Now in the graduated cylinder, we're supposed to measure along the meniscus. So that's this line here. What is this graduated cylinder calibrated in? Well, if this is 50 and this is 60, what do each one of these lines represent? Well, they represent 1 milliliter. So I can be certain of the 1 milliliter in this, but the tenths I'm going to guess. So what am I certain of? 51, 52. Is it past 53 or is it before 52? I'd say it's right at 52. I know it's not 53. I know it's 52 point. Now what am I going to do? I'm going to have to guess the digit after the 2, which of course would be the 10th. But do you think it's almost to the 53? So what would that put it at? 52.9? 52.8? 52.7 is kind of pushing it. But we're definitely saying here that we are guessing the 8. We were certain of the 2. What if I just put, say, 52? Now what am I saying? Well, I'm saying that I am certain of the 5, and I guessed the 2. Well, there's no way, because this number here, this line here represents 51. This represents 52. That's 53. This meniscus is just below the 53. It's above the 52, so I'm certain of the 52. So the 2, I'm certain of, so I'm going to have to go past this. What if I wrote 52.80? Now what am I saying? I'm saying that I was certain of the 8. Am I certain of the 8? No, I guessed the 8. There are no lines in between these lines. So there's no way that's going to work. 52.8 is the way that we would record that. Now here we have a thermometer. What's the thermometer calibrated in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like each one of these lines is a degree. So I can be certain of the 1 degree, and I'm going to have to guess the 10th of a degree. Well, is this line right on 30? It certainly is. So I'm going to write 30. Am I sure of the 3? Am I sure of the 0? I am, because the 0 would be considered the 1's position. So I'm going to have to guess the tenths of a degree. Is this tenths going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9? Well, it looks to me like it's right on the 30. So I'm going to guess 30 point, what? 30 point, it's right on there, 30.0. So this is where a lot of students have trouble, because in measurement, there's a difference between 30, 30.0, 30.00. All three of these measurements, in math we would say, well, they all represent the same value. But measurement-wise, they do not represent the same measurement. They all have different precision. So what do we have to do? We have to look at the device we're using to measure, and from the device determine how far to go past the decimal. If I wrote 30 for my temperature on this thermometer, what am I saying? Well, I'm saying that these lines aren't here, that it's just 20 and then 30. So in other words, I'm guessing the 0, this 0. Well, what if I wrote this 30 down here? Well, now I'm saying I was sure of that 0. And if that was the case, there would have to be tiny little lines here, here, and here, and there aren't. So this one's too precise, this isn't precise enough, this is perfect. And this leads us into what's called significant figures. So that's part 5. Part 6 will be on the way.